But here you don't go down to the left. Okay.
All right, you should have found, left side of the room, you found a strategy that's different than the ones I showed you. When I was setting up my strategy with the horizontals, what I was thinking right away was, if that first move by the vertical blocks my second choice, I have a symmetrical choice on the other end that I could do that'll still screw them up. So that's kind of what my mind was thinking. I had actually talked to a topologist once, and I said, mathematicians, fine, they love elegant solutions, they love beautiful mathematics, but they're also lazy creatures. We try to find the simplest way to get out of doing any more work. So I think in my mind that was the simplest way, so that I don't have to draw more boxes. I didn't want to draw any more of these. So that's kind of what I was thinking. But I think if you did the horizontals differently than what I did, you had to work a little harder to get a strategy working, because you couldn't utilize the symmetry as easily. So you couldn't knock off a whole bunch of boxes saying, well, if their second move was this, then I have a symmetrical second move, so I don't really have to draw the whole second half of the tree. Verticals, I think most of you tried the same thing I did, putting them in the center, and it worked. And that makes sense, right? David rotated his screen. It's really rotation. Okay, we're going to skip this. I actually took longer. I mean, when I do this myself, this is one of the things I enjoy doing, so it seems like time hasn't gone by, but it really has. So you want to see if you can do this for 6x6 and then an 8x8. If you do the 8x8, I recommend that it is hard to do the 8x8 because you really have to think about the strategy for winning on a bigger scale and draw more trees out. But if this is what you would like to do for your open problem project, there's open problems associated to domineering, and then you will have to try to do this. And it doesn't take, it's brute force. There's not any fundamental theorem of algebra you need. There's not, let's assume that the limit exists. None of that. You just sit there and draw trees and by brute force figure it out. So it's not terrible, actually, in some ways. If you compare it to the theorems that you have to prove in advanced calculus. I usually do an info sheet to find out what classes you're in. How many of you are in advanced calculus? Okay, so you get some ugly theorems that you have to prove there, where they're not obvious what you're supposed to be doing. How many of you are in modern algebra? No, that would have been a nice class with this. But those are kind of ugly proofs where you have to figure out, it doesn't make sense why they just took the strategy they did. So some open problems. You can make your square different sizes. We did a 4x4. I suggested you do a 6x6. We started off with the 8x8. That's the default that I get on the app for my phone. 12x12, nobody knows if there's a first player win and what that strategy would be. So if you select this, I'll give you some starter papers because I found some starter papers, and there's a thesis. What's nice about a thesis is different than a paper. People have to explain every little detail like they're explaining it to my mother. So my mother hates math and she doesn't want to hear anything about math. So if she's hearing it, they have to really spell it out. So that's what's nice about a thesis. This is a winning strategy. Some of you started to talk about minimal number of moves. I could have done this faster. That's an optimal strategy. This is how a mathematician thinks. If you said something like that, you might want to start looking at graduate schools because you're heading in that direction. So some more types of questions you can ask is, what's the optimal strategy? What's the minimal number of moves to have that first player win? Does it matter if the first player is horizontal or vertical? In this case, for the 4x4, it did not. That's what that little exercise was. Your verticals on this side of the room were able to come up with a winning strategy. So it doesn't matter. If the first player starts and knows what they're doing, they're going to win. Is there a board size where the first player cannot win no matter what they do, but the second player will win? That's a much tougher question. There's on the Wikipedia site for domineering what they already know. If this is not on the table, then we don't know it yet. You can't probably see it from the back of the room, but there's V's, H's, 2's, and 1's in this table. And M by N, the columns are N's and the rows are M's. So this is a you can just look and say, what if I have a 4x4? We just did the 4x4. The first player can win no matter what. If there's a 1 in there, it means the first player can win no matter what. If we do a 3x4, though, the first player has to be horizontal in order to win. So there's an H in there. So that's what this table means. And so, for example, the 12x12 is not on here. That means it's not known. So you can just pick any of them. I'm just going to do the 12x12 and figure it out. So some more open problems. So all of these are separate problems. If you want to take domineering and work on the 12x12, that's fine. You could take cram. Cram is really wide open. They don't know a lot about it. Determine the winning strategy for an n by n board for n odd. They don't know any of those. Solve 1 by n. Just find the winning strategy for 1 row and columns for both. First player being the normal play or misery play, where the first player who can't move is actually the winner. Okay, any questions on that? Again, it's first come, first serve. I'll be giving more as we move along. So tricks are what we don't call them tricks in math, we call them heuristics. There's something called greedy strategy. What a greedy strategy is, it's a strategy where the player's always trying to maximize or minimize a quantity related to the game position after the move has been made. So the trick that I showed you on the first day, heuristic that I showed you on the first day, where I was placing my pieces in a way that blocked out the other person, I was trying to minimize the open locations for the vertical piece. That's what I was doing. So I was playing in a greedy way. It's a nice way to start when you start playing and you want to win. Obviously, I would think the object of any player is to win. So that's a nice way to start. So that would be a greedy strategy. So remember I asked you whether if I start with my horizontal in that position, will I win for sure? I don't think so. I don't think so. I think there is some kind of configuration if I start there that the vertical can win. So it's just a greedy strategy that if the second player didn't really know what they're doing, I might be able to force my way upon them. I think you have to start in the center to really come out with a nice, quick way to win. Might be more complex, but it seemed to me that there was a way for the verticals to win. Okay, I'm gonna end class today with dots and boxes, which is another game, because I want to show you where greedy play doesn't always work. So they talk about dots and boxes quite a bit, and I found out there's an app for that too. So you can just download it on your phone and play. What's nice about this kind of class is it's so different from other classes you've taken. Calculus 2, you just had to integrate a lot, and you had to sit there with a piece of paper and pencil and integrate. Calculus 3, you had to do something. Linear algebra, it's not like you could sit around in a doctor's office and think about linear algebra comfortably. What's nice about these kind of things is that you can just download it on your app and play it wherever, and then you start getting a good feeling for it. So I found a website that would play it, and here's the object of the game. And I'm going to lose because I'm playing against a computer. The idea is to set up, like I'm the first player here, I'm going to put a horizontal here, and the computer just put a vertical here. I'm going to put a vertical right there, and they put a vertical there. The first one of us to close up boxes. So I don't want to put a horizontal here because then the blue will put a horizontal on the bottom and they'll get that box. Anybody who completes a box gets the box. The one who has the most number of boxes at the end wins.
If you fill in the box, you go again?
Yes, and you get to go again. Now you get to play it again for math class. So soon I will be in trouble. Because they can go again once they make a win. I played this in the library for some time, and I was able to get three boxes against it. So I'm not close to getting the winning strategy. So what I would like you to do is pair up with someone. Always bring your laptops. Pair up with someone who has a computer. This website is just called dotsandboxes.org, and play. And I think it allows you to play. You can set up so you don't play against the computer. No, I think both of you can just advise each other on what you want to do. So you can go to dotsandboxes.org because I felt it was coded well. They don't know what they're missing.